The second law, if you recall, states three things. A force acting on a mass will cause the mass to accelerate in the direction of the force. The acceleration is proportional to the force and inversely proportional to the mass of the object. That's the second law. If we look closely at this law and look at what it really says, saying a force acting on a mass will cause the mass to accelerate, we're looking at the relationship between three things: force, mass, and acceleration. And what this law really says is this. It says force equals mass times acceleration, which is expressed very clearly in this equation. F equals m times a. Force is equal to mass times acceleration. If you know the mass of an object and you know its rate of acceleration, you can calculate the force that's causing that acceleration. Rather than spend a lot of time just talking about it, let's go ahead and work a problem. Here's a question. What force is needed to accelerate a 3 kilogram skateboard at 2 meters per second squared? And we set the problem up in 3 steps. The first thing we want to do is we want to identify the information in the problem. It says what force, so we're looking for the force. Is needed to accelerate a 3 kilogram skateboard. Well, we have a mass, and we also have an acceleration, 2 meters per second squared. With this information, we can use this equation, force equals mass times acceleration, to calculate the force. Works like this. Like I said, we set it up in 3 steps. The first step is to write down the equation, force equals mass times acceleration. The next thing we're going to do, we're going to plug some numbers in here. The mass, 3 kilograms, times the acceleration, and the acceleration is 2 meters per second squared. When we work this out, 3 times 2 is 6. What is the unit of measurement? And if you look at this, you see nothing factors out, nothing cancels out. So the unit is simply kilogram meters per second squared, like this: kilogram meters per second squared. That's the unit of measurement, and that is the unit of force. That's the unit that force is measured with, kilogram meters per second squared. But you don't want to have to write down kilogram meters per second squared all the time, so it's a good thing that by convention 1 kilogram meter per second squared is equal to 1 Newton. Just like that. So 1 kilogram meter per second squared is equal to 1 Newton. The symbol for a Newton, a unit of force, is an uppercase N. So our answer here, the force is equal to 6 newtons. There is our answer. It takes a force of 6 newtons to accelerate a 3 kilogram skateboard at 2 meters per second squared. Problem solved. Now let's go ahead and work a few more example problems just to help you get used to using this equation, force equals mass times acceleration, in some different ways. And the first question simply says, what force is needed to accelerate a 20 kilogram mass at 20 meters per second squared? Well, we're looking for the force again. We have a mass and we have an acceleration. So we can use this equation, force equals mass times acceleration. And the mass, of course, is 20 kilograms times the acceleration, 20 meters per second squared, which is the same as 20 meters per second. And so when we work this out, 20 times 20 is going to give me 400. And what is the unit of measurement? Well, we know it's kilogram meters per second squared. Nothing factors out here. And that is the same as 400 newtons. So there's our answer, 400 newtons. Remember, of course, that the unit for measuring force is the Newton, which is the same as the kilogram meter per second squared. Remember, 1 kilogram meter per second squared is equal to 1 Newton. So a Newton is the same as a kilogram meter per second squared. You don't have to write down kilogram meters per second squared all the time. All right, next question. How much force is needed to accelerate a 200 kilogram motorcycle at 4 meters per second squared? And again, we're looking for the force. We're given a mass and we have an acceleration. So the equation is still force equals mass times acceleration. The mass, 200 kilograms, times the acceleration, which is 4.0 meters per second squared. So the force is 200 times 4. It's going to give me 800. And what is the unit of measurement? You're right, it's a Newton, named after Isaac Newton. And there's your answer, 800 newtons. Question 3. Now this is a little bit different. It says, what is the weight of the 200 kilogram motorcycle? Well, we need to go back to what we learned before. Remember that weight is a force. If you sit on a chair, your weight becomes the force that you're applying to the chair. So weight is a force, and because it's a force, we can use this equation, force equals mass times acceleration, to calculate weight. But we're going to change this equation just a little bit because we're specifically talking about weight. We're going to say force of weight, so that becomes F sub W. The W stands for weight. And instead of just using any acceleration, we're going to change this to the acceleration due to gravity. So our new equation becomes force of weight equals mass times the acceleration due to gravity. Remember, isn't it gravity that gives an object its weight? No gravity, no weight. So gravity, acting on the mass, gives that mass its weight, a force of attraction between two objects like you and the earth. So let's go ahead and solve the problem. Force of weight is equal to mass times gravity. Next step, force of weight is equal to the mass, which is 200 kilograms, times the acceleration due to gravity, which is the acceleration that gives this mass its weight, the force of weight. And so that's going to be 9.8 meters per second squared. And so the force of weight here is simply 1,960 newtons. And if you want to round that off to 2,000 newtons, that's fine. So there's the force of weight. Remember, these two are the same equations. Force equals mass times acceleration, and force of weight equals mass times gravity. It's just that we use this second equation whenever we're talking about the weight of an object because it's specifically dealing with weight, and we want to say that when we use that equation. Well, question 4. Let's see. A 200 Newton force accelerates a scooter at 3.0 meters per second squared. What is the mass of the scooter? Let's go ahead and identify what we have in the question and figure out what we're looking for here. It says a 200 Newton force, so we're given a 200 Newton force, that's F, accelerates a scooter at 3.0 meters per second squared. That's the acceleration. And this says what is the mass, M, so we are looking in this case for the mass. Well, now the equation we have says that force is equal to mass times acceleration. If we're looking for the mass, we're going to have to rearrange this equation. Now remember, you can do this algebraically, but a while back I gave you a method for rearranging an equation like this. What I said was if you draw this magic triangle and you put the equation in the triangle, in this case force is equal to mass times acceleration. Remember, this horizontal line is division, the vertical line is multiplication, so this is force equals mass times acceleration. If we want to know what the equation is for force, it's right here. Force equals mass times acceleration. If we want to find acceleration, acceleration is equal to force divided by mass. Right there. And now if we want to find mass, mass is equal to force divided by acceleration. Mass is equal to force divided by acceleration. And that is the equation we're going to use in this situation. We're not going to use force equals mass times acceleration because we're actually looking for the mass. So this equation now becomes mass is equal to force divided by acceleration. Well, all we have to do now is plug some numbers in. The force that we're given is 200 newtons. The acceleration is 3.0 meters per second squared. So when we work this out, the mass works out to 67 kilograms. Now you might look at this and you might say, well, how did I get the kilogram down here? Well, keep this in mind. This Newton that you see right here is actually a kilogram meter per second squared. That meter per second squared is above this division line right here. And this meter per second squared is below a division line. So that factors out, and so does that. And so what comes down is going to be the kilogram, and that's what you see in this answer. So the unit in the answer is going to be kilograms, which is good because we're looking for a mass, and a kilogram is actually a unit of mass. So it just helps you check and make sure that you set the problem up right. All right, next question. Let's take a look at number 5. What is the acceleration? Now in this case we're looking for the acceleration of a 2,000 kilogram airplane. That's a mass. If the jet engine can produce a maximum thrust, and the thrust is a force, you see it's measured in newtons, of 3,000 newtons. So this is the force. So here we're given the force, we're given the mass, and we're asked to find the acceleration. Well, if we go back up here to this magic triangle, acceleration is equal to force divided by mass. Right there. Acceleration is equal to force divided by mass. So I can set this problem up. Acceleration is equal to force divided by mass. Next step, plug in the numbers. Plug in the units of measurement. Force, which is 3,000 newtons, divided by the mass, 2,000 kilograms, is going to give me an acceleration of, how about 1.5 meters per second squared. Now again, remember that that Newton is actually a kilogram meter per second squared. So that kilogram is going to factor out right there. And so the meter per second squared is the unit that comes down to our answer. So the answer here is simply 1.5 meters per second squared. Now we're ready to work on question 6. And question 6 is a little bit different. Question 6 says, what is the acceleration of each cart above? And there are 2 carts. Well, if we look at the information that we have, force, mass, and acceleration, we actually do have the force. The force that we're going to use is going to be the net force. So this becomes F subscript net. That stands for net force. We're going to use the mass, and we have that. We have the mass. The mass of the cart is, in this case, both of them are 10 kilograms. The acceleration, well, in this case, for both carts, we're looking for the acceleration. So we have the net force, we have the mass, and we can calculate the acceleration. Now remember, we need an equation that says acceleration equals, not force equals. So we're going to have to use, in this case, I'm going to use that magic triangle again. Remember that magic triangle says force equals mass times acceleration. So if I want to calculate acceleration, acceleration is equal to force divided by mass. And of course we're going to be using the net force for that force. So this equation over here becomes net force divided by the mass. And so when we set this up, it looks like this. Acceleration is equal to the net force. Well, we have positive 40 newtons plus negative 30 newtons divided by the mass, and the mass was 10 kilograms. So what does our acceleration work out to? Well, positive 40 plus negative 30, that's going to give us positive 10, and positive 10 newtons divided by 10 kilograms, well, that's going to be 1. And what is the unit of measurement? Remember, this is a newton up here, and a newton, if you recall, is actually a kilogram meter per second squared, and we're factoring kilograms out of this. So what unit comes down here? Meters per second squared. So there is 1 meter per second squared. That's our answer. Let's go ahead and solve this for the second card. And we're going to use this equation, acceleration equals net force divided by mass. So the next step, acceleration becomes positive 12 newtons plus negative 18 newtons divided by the mass, and the mass is still 10 kilograms. Remember, the mass of both of these carts was the same. So now this becomes acceleration, and positive 12 minus 18, that gives me negative 6. And negative 6 divided by 10, that is going to give me negative 0.6, in this case, meters per second squared. So the answer here is negative 0.6 meters per second squared. Let's stop for a minute and look at these two answers. We have two carts. They both have the same mass. We have a large force on one and a small force on the other. And so you see that change in acceleration. A large force produces a larger acceleration, in this case 1 meter per second squared. A smaller force simply produces a smaller acceleration, 0.6 meters per second squared. And that's one of the things that Newton's second law says. That's the second postulate in Newton's second law. It says that the acceleration is proportional to the force. The bigger the force, the bigger the acceleration. Smaller the force, the smaller the acceleration. So, there's your problem solved. Alright, let's go down here and work on question 7. It says, what is the weight of the cart? Well, remember that weight is a force. So we're dealing with this same equation, force equals mass times acceleration. But we're going to change it a little bit. We're going to say force of weight equals mass times not just any acceleration, but that specific acceleration, the acceleration due to gravity, g. So force of weight is equal to the mass, that's 10 kilograms for both carts, times the acceleration due to gravity, 9.8 meters per second squared. And so the weight of both carts is going to be simply 98 newtons. Why is it newtons? Well, because a kilogram meter per second squared is the same as a newton. So there's problem 7 solved. Alright, question 8 deals with this rocket, and it says simply the mass of a rocket shown is 6.0 kilograms. What is the acceleration of the rocket? Well, what information do we have? We're working with force, mass, and acceleration. We ask ourselves, do we have a force? And we do. The force that's causing this object to accelerate forward here is going to be 200 newtons. So we have the force. Do we have a mass? We do. The mass is simply 6 kilograms. And we're looking for, in this case, the acceleration. So the equation for acceleration, remember that F equals m times a. So we're going to solve this for acceleration. We're going to have to rearrange that equation, and acceleration is equal to F over m. A equals F over m. Set this up. The force, 200 newtons, given in the problem, divided by the mass. In this case, the mass is 6.0 kilograms. And the acceleration of our rocket appears to be 33, and that's going to be meters per second squared. And again, let's look at why it's meters per second squared. This newton is actually a kilogram meter per second squared. This kilogram factors out, so meters per second squared comes down to our answer. That's how we get the derived unit in the answer. And you want to remember, the answer isn't correct unless you have the correct unit of measurement attached to it.